Hello, let me try again. I'm going to have to cut top and tail this then if I'm going to fat finger. Hello and welcome to the vBrownBag podcast. I'm Alistair Cook, and this is an extra special edition of the vBrownBag podcast that's been recorded in a quiet back corner of the internet, and it's hitting a really interesting area, which is around what hyperconverged infrastructure is. And it's an area that we're seeing particularly recently. We've seen a new entrant into the hyperconverged market, and I think it's an area that's going to be very hot for a while. Little introduction to the vBrownBag for those who aren't familiar with us. We are the community's way of helping itself to learn. So community members helping other community members learning about things in the virtualization and enterprise IT infrastructure areas that are useful to them. We will be doing tech talks at the EMEA edition of the VMworld conference, as we have in the last couple of years. There's still plenty of opportunities to come up and present with us, so head up professionalvmware.com and look for some of the blog posts there. We'll also be at the OpenStack Summit in Paris, which means for me 2 trips to Europe this quarter, and we will be doing a heap of tech talks there. Lots of podcasts, lots of time zones, lots of good content. But today I'm joined by 3 guests, 3 gents who have agreed to come in and represent some of the leading vendors in the space of hyperconverged infrastructure. Most of you will be familiar with at least some of them. Mike Laverick, if you've been in the industry as long as I have and as many grey hairs as I have, then you used Mike's guides many years ago around your upgrades and versions of vSphere. And I've just seen a typo in Stephen Poitras' name here. Stephen is with Nutanix, and I had the pleasure of sitting next to him when he did the first public showing of the Nutanix OS 3.5 last year at Tech Field Day. Finally joining us is Jesse StLaurent from SimpliVity, and I'm less familiar with Jesse, but I did meet him in VMworld in Europe, USA today, this month. So I'd like to get the guys to just quickly introduce themselves and their background, and since I've just mentioned Jesse, I'll get you to introduce yourself.
Sure, thanks. My name is Jesse StLaurent. I'm VP of Product Strategy here at SimpliVity. So spend a lot of time with customers and the partners as well as working with our strategic partners, folks like VMware and folks like Cisco, and then also engaging with our engineering teams and product teams, making sure that the ideas we're hearing in the market are the right ones that we're actually bringing to market from through the engineering teams and through our partners.
Excellent. And then Stephen Poitras, who I particularly asked Stephen if he would come and join us because he is such a big contributor to the community around the products that he supports with the Nutanix Bible. And if you're working with the Nutanix solution, just Google up Nutanix Bible and you'll find Stephen. Could you introduce yourself at all, Stephen?
Cool. Yeah, thanks, Alistair. Hey guys, my name is Steve Poitras. I'm a solutions architect here at Nutanix. As Alistair was saying, I write the Nutanix Bible and really spend a lot of my time in the trenches with the Nutanix product, figuring out how to make it better, tweak it, and then also produce a lot of our reference architectures and best practices guides. So pleased to be here today.
Great. And of course, the man who needs no introduction, who nonetheless is going to introduce himself, Mike Laverick.
I'll keep it brief. Yeah, Mike Laverick is the name. Been around in VMware technologies for nearly 10 years. Started off as an independent, joined VMware 2 years ago as the senior cloud infrastructure evangelist within the competitive team. And I've recently moved teams to work with the new vReal technology and products, helping both internal staff, customers, and partners integrate and use the new technology from VMware.
Excellent. A quick introduction to myself. I'm Alistair Cook and I'm a New Zealand-based consultant and trainer. And for disclosure, I should say that both Nutanix and SimpliVity have been sponsors of the vBrownBag podcast, and that my work as a trainer has been for Nutanix and for VMware as well. Not yet for SimpliVity, but maybe watch this space. We're discussing hyperconverged infrastructure as a new way, relatively new way of deploying a virtualized infrastructure. And so I wanted to first highlight some of the problems with the old way, how things worked with a non-hyperconverged infrastructure, and then what hyperconvergence means and the parts that make up a hyperconverged solution. Then we'll head on into looking at the benefits of hyperconversion, particularly addressing all of the problems that we identified in the old way of working. And since all the three gentlemen who are giving up some time to be with me represent vendors, I thought I'd also give them an opportunity to outline to you how the different hyper-converged solutions that they represent sort of come together, the value propositions behind them, because not only is it important to understand the class of things that is hyper-converged, but I think really critical to understand the differences between the products to help you to evaluate what's, if you're going down the hyper-converged road, what are some of the things to think about between the solutions. But primarily we want to look at the old ways of working. And so, guys, what do you feel were the biggest problems with non-hyper-converged infrastructure that we're seeing hyperconvergence addressing and solving? And I should probably be nominating people to answer, shouldn't I?
You should.
Well, Mike, since you spoke up first, and I know I can rely on you to talk, what do you see as being the biggest issues that hyperconvergence addresses?
Well, I think we have one of the ironies I've been trying to stress to people is, though we have this thing called convergence and hyperconvergence, there hasn't been a convergence around ways of dealing with this problem or dealing with this particular issue. So there's lots of varieties of both convergence and hyperconvergence. Or put it more simply, you know, even if you look at convergence like vBlock and FlexPod, those two different structures or technologies are very different from each other in the way they're constructed, and they're very different from the way they're actually delivered to the customer. I think perhaps VMware's position on this is a little bit different from other vendors. We don't actually see the old methods as being a problem as such, but just a different way of delivering that infrastructure. So that there are many happy vBlock and FlexPod customers, and it may be for those particular environments, you know, those technologies are good for them. It may be that in other environments, a more hyper-converged approach might be more appropriate. So I guess I've always been a bit wary of promising panaceas, solutions to all your problems, bringing this technology, everything will be fixed. In my experience in IT, you just inherit different problems from different infrastructures. It's depending on how well you deal with those problems. I think maybe the road to convergence has already sort of been burnt a little bit by people like VCE and the FlexPod people. And so a lot of people looked at vBlocks and things like it and said, we need to change the way we manage things, trying to manage the environment as a whole, rather than a storage team and a network and a compute team. So if you like, I think hyperconvergence is that road taken to the next logical level to some degree.
So that's one of the things we should probably differentiate is hyperconvergence from convergence, but I think that's...
come on to that later.
Yeah. And so, Jesse, as you're going out and talking to customers about their pain with their infrastructure management, what sort of symptoms, what are the kind of key indicators to you that they're a good candidate for hyperconvergence? What sorts of pains do you hear them having?
So I think it really differs by which portion of the market you're talking to. The problems that are faced in sort of SMB versus mid-market customers versus enterprise customers are actually quite different. I think there's a couple common themes, though, that go across that. And in the end of the day, the problem here is about efficiency and about economics. So I'm an engineer at heart. My background is in computer science. And while I love cool widgets, in the end of the day, the coolest widget might not actually move the market if it doesn't solve an economic problem. And so I think as a technologist, we always have to accept that economics drive so many of these decisions. So we look at it as an efficiency aspect, which is if you have the same staff, which most folks organizationally, there's not a tremendous amount of staff expansion in these organizations, then making the management of the environment efficient is a key, right? Getting rid of the complexity and really breaking down some of the barriers so that you can have the virtual machine administrator managing the entire infrastructure, whether it's backups, replication, restores, all that functionality, turning it into something that's within the comfort zone of the VMware administrator, I think is one key of this space, and that's where we've really seen struggles between some of the silos within these organizations, in that the complexity of these solutions and the existing solutions, what from a marketing perspective get called best of breed, it's a nice way of saying best of breed, also most complicated to implement in most cases. So I think that's one of the key takeaways, is the the manageability of and overall efficiency of convergence.
I think there's a valid point being made there, because part of the reason that things like FlexPod and vBlock came about was to try and produce a consumption model that would make it easy for these technologies to be consumed either by a reference architecture or by something that's racked up and then shipped to the customer. So there's still that kind of three-way split between customers who buy their various bits themselves individually, rack them up individually, and then expect them all to work. Then customers who've gone down the converged route, where they maybe engage with VCE or with a FlexPod partner, and then the hyperconverged kind of route. But that statement about economics, I think, is an important one. A lot of these converged architectures are quite big ticket items. So, if you're an insurance company or a financial service, maybe it's not a difficult thing to get that approved by whoever signs off purchase orders, whereas in other companies, it then becomes the stalemate is who's the person who signs off on this particular spend. And I think one of the attractions of hyperconverged is you build up block by block, bit by bit as you need. And because those units tend to fall below a certain value level in terms of signing off a PO, sometimes the logistics of getting things approved from a cost spend perspective is easier.
Yeah, I think that's this units of scale concept of when I outgrow what I've already bought, how much do I need to spend for another? If you've got a $4 million vBlock, then it's another $4 million spend. If you've got a smaller reference architecture that's maybe $100,000 for the unit, or a couple of $100,000, then it's smaller, but that's still many organizations
and I guess
quite
we
a lot.
Don't want to, I guess some of us might look at it and think, well, it needn't be an either or. Those converged architectures might work very well in very large scale out data centers, but if it's an SMB or Robo or BDI deployment, then maybe a converged architecture, hyperconverged architecture is more appropriate. So a kind of blended solution is something that some customers might just by default end up living with, whether they like it or not.
And I think the other thing we always need to bear in mind is that in discussion, it's always feels like we need to select one winner, but the reality is, as we've highlighted, that there's going to be different solutions for different customers and different sets of problems. Stephen, we haven't heard your voice. Have you got some thoughts about the problems in the old ways, or are you so embedded in making the new ways work that you can't cast your mind back to these pieces of pain?
Well, yeah, I mean, I think Mike and the crew and Jesse definitely covered the key points very well. And so actually, I mean, prior to joining Nutanix, I was actually at Accenture where I did and recommended a lot of vBlock and FlexPod deployments. So, I think to Mike's point before, there are going to be scenarios where both deployment models actually come through and work very well. But a key thing for us is really just about efficiency and simplicity. At the end of the day, people really don't care about infrastructure. They care about the applications or services that run on top of that infrastructure. And, one of our key purposes and points is just to make the infrastructure part simple, whether it's at 3 nodes or 3,000 nodes, and just allow them to get really focused on what their core is, which is the applications and services, which is what IT is really focused on at the end of the day.
Cool. All right. So, and I guess we should talk about what hyperconverged means to us. And for me, the idea of hyperconverged means that you don't simply assemble these collection of parts. So conventional infrastructure was go to your integrator and grab a menu of pieces of storage arrays, of servers, of networking devices, and assemble a kind of a la carte. I want to say it was ordering for a menu. I'm trying to do a parallel to ordering a fixed menu versus an a la carte menu, but I kind of feel the original method was you actually went to the supermarket and bought the ingredients, and you had to cook your own meal yourself. You had to assemble these sets of disks and these controllers together, or you might buy that collection and this collection of servers, and you got 15 different options on each model, and you had 4 different vendors of servers, so you had to select from dozens of different servers and networking configurations, and you had to assemble these together, and this was the old best-of-breed model. And then the converged infrastructure was, here's the menu, here is the cooked dishes that you may wish to eat. And you can imagine that if it's dinner time, the a la carte, just give me the cooked dish rather than send me to the supermarket at dinner time. Much simpler to deploy out. I can't extend the menu then, the metaphor then onto hyperconverged, where you're condensing all of those different functions into one physical appliance. I think that's, to me, one of the key things in hyperconverged is that it's condensing particularly storage into the compute nodes. And Stephen, would you feel that that's one of the important physical features of hyperconverged?
Yeah, no, absolutely. So, I mean, if you look at a traditional SSD device and the amount of IOPS or throughput it can actually facilitate, realistically, you're going to get the best performance no matter what if you're going to be accessing that over local bus speeds. If you look at a traditional array and then you put, say, 24 or 48 SSD devices behind those controllers, your network's not even going to be able to facilitate all the throughput that those SSD devices can facilitate. So that's where one of the key things for hyperconverged was really natively converging the storage near the compute. So rather than having to go over the network, which can become a bottleneck, you can actually access that all locally on a local bus speed, which gets even better with NVMe.
Yeah, I think one of the other things to sort of trying to wash out as much complexity as we can in the environment is that collapsing of networks, not having a separate storage network typically, or at least not a separate storage network technology, having the storage network be 10 gig Ethernet typically, the same 10 gig Ethernet that's often used for virtual machine access. Jesse, is that kind of one of the sort of themes that you see as well?
It is. I mean, I think this comes back to the theme of efficiency we talked about before, right? Which is one of the things we typically show customers is the stack of devices in their data center, and it starts with the most obvious ones at the top of the stack, which is servers running VMware. But as you go down the stack, they've got storage and they've got backup to disk devices and they've got all these other devices, flash accelerators, cloud gateways. And if you look inside every one of these devices, they're all Intel CPUs with some memory, some storage capacity, and some networking connectivity. In the end of the day, there's this interesting phenomenon of we decided for many reasons to virtualize all of our business applications, right? To create a single shared pool that we could run all the business applications on. But for some reason, we still have dedicated pieces of hardware in most cases with isolated islands of resources in the data center for most of the infrastructure applications. And this is where I think there's a real opportunity, and there's a spectrum of hyperconvergence, and everybody might have a different opinion of how many devices you have to pack in to be hyperconverged. But I think the common theme is you have to start eliminating more of those islands of resources. If you're not doing a backup to your backup to disk device, the CPUs sit completely idle. Right? It's the equivalent of a SQL server that only does off-hours reporting, consuming dedicated CPUs during business hours. We need to apply the same rules we've applied to our business applications to the infrastructure applications as well.
Yeah, I think that
just to add on to that,
you go, Mike.
Yeah, I was going to say, just to add on to your analogy, I once had a delegate out of eMugs saying that they were sick and tired of speaking to the bun team, the burger team, the relish team, the gherkin team, whenever they wanted a burger. They want the burger, they're not really that interested in the constituent parts. But if you want to take your analogy to the next level, maybe hyperconvergence is the drive-through, where when you drive in, there is a limited amount of choice, but what you take from that limited amount of choice is the most popular configurations of the bun or the meal that you're looking for, and it comes in a couple of set sizes, but there isn't too much opportunity for customization excessively, so otherwise you're going to hold up the process of consumption.
Yeah, I was going to go for the next place on my metaphor about dinner was to go for the set menu. That hyperconvergence gives you typically the solutions have a fixed configuration and you choose the one that best suits your current hunger.
Mm-hmm. That's the one.
And I think one of the other key things in hyperconvergence is that you use a smaller number of tools to manage the environment. You have less single panes of glass, or single glasses of pane, as commonly referred. That you don't have a separate management tool for the storage array completely isolated from the way that you manage everything else. There is a much better integration of the management between the different pieces. And I think that's one of the places that we head to some of the real benefits of hyperconvergence, is that there's no longer the siloing of management, that there is this converged management. And I think we've already sort of touched on a little bit that it tends to converge down on the virtualization team looking after this, and the organization's large enough to have one.
I think it comes down to the VMware administrator, right? At the end of the day, there's been this if we rewind the clock, this interesting change in sort of the power of the data center, right? It used to be that the Unix guys or the mainframe guys, if you go back even further, really were the ones that wielded the power in the data center. And then over time, I think the storage team had a tremendous amount of power, and the Windows team, to a certain extent, was looked down upon in the data center. I mean, that's not data center technology. And then suddenly VMware came along, and the Windows team said, hey, this solves a great problem for us, and they became virtualization experts in a lot of cases. And now there's been this tremendous power shift in the data center, where we have the same folks that were the Windows team are now on the top of the pyramid in terms of virtualization driving the majority of decisions in infrastructure. And I think that's a fundamental change in how decisions are made in the data center. And it really brings it back to, from a management experience, that's the target audience, right? The person managing the VM itself, as much as the management experience can disappear into the day-to-day workflow of that administrator, the simpler the environment becomes.
Yeah, sort of that frictionless management, the removing unnecessary management layers. And typically we'd look at the storage team as being one of the two that, from the point of view of the virtualization team, the storage team has been one of the bottleneck places, because they've been disenfranchised when we said, just give me a series of 2 terabyte LUNs, don't worry about what's going to be on them, I'll manage that. And the hyperconvergence tends to hand that storage management over to the virtualization team. As you say, initially it was actually the Unix team, because back in the ESX 2.5 days, and I'm showing my age here, back in the ESX 2.5 days, it looked like a Linux box when you looked at an ESX server. And I've definitely seen in my years teaching the courses, much more of the Windows guys coming out and taking it over, as you say, and becoming more of the powerhouse as the organization goes virtualization first. So yeah, the hyperconvergence enabling these guys to actually see what's going on inside the storage and take away some of the provisioning, management, and troubleshooting bottlenecks is really useful. Let's think about the parts that make up a hyperconverged infrastructure. I think we all agree that it's x86 servers running a hypervisor. I think everybody works with local storage, because that's the way you get your relatively small unit of scale, is to be able to work with x86 servers. I think fast networking, 10 gig Ethernet at reasonable prices, is one of the big enablers for this, and allows us to pull out the fiber channel network. And I think that's one of the key things to being able to do hyperconverged, is to be able to put your storage and your virtual machine and your management access all over that same 10 gig network. Local storage, of course, this is one of the comic things that Mike and I have discussed a little in the past, was that we spent years teaching people to take all of the storage out of their x86 servers and put it into some centralized, typically SAN-based array, and now we're teaching you to put it back inside all of the x86 servers and use something else to assemble it together. Mike, does that still amuse you every time you need to go through that process?
It does, and I mean, I was struck by something that was said earlier about where the power is moved around in the data center, because it used to be years ago that's what people did. They put Windows on a server, they filled it with direct attached storage, and then they used some kind of sharing mechanism, even if it was Windows shares, to make that resource available to end users. So for some of us, it does sort of feel like we've jumped into a time machine, John DeLorean, gone back to the past to a place where we were at before. But I think, as mentioned earlier by the other two guys, the key differentiator now is the use of SSD and a distributed shared storage system, be what that might be, by any one of the vendors. Those two things coming together makes this a different proposition from what we've seen before. I'm glad that you mentioned the 10 gig requirement or the 10 gig portion of this, because I think that's something that's often overlooked, especially in SMB and robo environments, because though 10 gig is coming down in price, it's still something that you don't necessarily see in the various segments where people are wanting to deploy hyperconvergence. I guess the other difference is whether the hypervisor is already there when you set up your hyperconverged system, or whether once you've powered it up and got it working, whether the hypervisor is something that you put on afterwards. That's another kind of consideration as well. But yeah, I think a combination of SSD and a distributed shared storage system, be what that may, is what's making this possible. If you think about it, even 2 or 3 years ago, SSD in servers wasn't really that common or even thought about, whereas it's now a kind of, this is something that we're going to do, and it's all to do with the cost and capacity of SSD becoming more accessible to a greater number of people than it was in the past.
Yeah, and Stephen, do you think there are any other elements that would be required to make a hyperconverged infrastructure?
I mean, those are kind of the key ones there, and I think really, as Mike was mentioning, SSD is really one of the key enablers that allows us to create this massive scale distributed storage platform. And then the other thing, and you know, this is going to be, I wouldn't assume too controversial, but you know, there's also people that have different approaches to hyperconvergence as well. Obviously, you look at all of us today, we converge or natively converge compute and storage together. But then also, you know, kind of in the same quote-unquote hyperconverged space, you also see some vendors that are converging storage and network, et cetera. So, you know, there are some people that have different kind of approaches on it. But obviously for us, it is, you know, natively converging storage, SSD and HDD on compute using x86 as a standard unit. So.
Yeah, and so I think that definition seems to fit fairly well. Jesse, do you think there's anything that you would add or subtract or change in this?
Well, so the thing I would add, and I think it's implicit in what we've all said, is the scale-out nature of these systems. So I think it said you have creating distributed shared storage, but I think this is one of the major innovations from an industry perspective that's easily overlooked in terms of what makes hyperconvergence viable. If it was just a fixed configuration of 2, 4, 6, 8, 10, doesn't matter what the number is, systems in a rack that became a single hyperconverged entity, I don't think that would be nearly as interesting. I think what's become key to making this market interesting for customers is all the things we've talked about, plus the fact that they can start, depending on which technology we're talking about, is with as small as 2 nodes, and in our case, without 10 gig in small environments. And then if they decide they want to grow that, you can add more and more systems into the environment. So the ease of entry into this market, I think, is really enabled by the fact that it can scale out, and it doesn't have to be a large-scale decision to the overall environment. It can be a decision about, I want to start with a small deployment, and then I want to grow that deployment over time. And that removes a tremendous amount of risk from the decision-making process. Someone mentioned earlier a multi-million-dollar vBlock. There's a huge amount of risk to an IT buyer if you purchase that kind of decision, and you have to make sure that the sizing is precisely accurate, right? I mean, it's a bad day to either to undersize that system and realize it 6 months down the road. In a hyperconverged environment where scale out is a core part of it, you just plug more systems in and the environment scales out with you.
Yeah, I think that's probably the biggest feature that I've left off this slide is the ability to incrementally grow, and I see a huge value in that to customers. There's a lot of workload types.
There is a lot of value to that scale out, add a bit as you go along. Although I think, if customers are buying them in dribs and drabs, what they'll find is the node that they add, that's the 32nd node, maybe cost them the same amount as the first node they had. So there is an element of, if everybody talks about hyperconverged being designed on commodity-based hardware, but sometimes you don't get commodity-based pricing until you start buying in volumes. So I like hyperconverged the way you can grow bit by bit, block by block. But if you're really buying them, it's a bit like buying PCs. If you only buy 1 or 10 PCs at a time, you're going to pay a different price than if you were coming in and saying, I want to buy 500 PCs for a new site. So there's an element of trading off on cost based on how many of these individual nodes that you have. If you truly buy them one at a time with a month gap between them, that gives you, I would have thought, less leverage over the vendor to try and squeeze on price because you're bringing a particular sized offering to that vendor that they would not get if they were going to another customer.
Yeah, and I guess the cost of slotting in one additional node in your cluster every month for a year is quite different to the operational cost of deploying 12 nodes in one hit. And so there may be some interesting economics around the time value of the money versus the discounts you can get versus the operational activities that are required. I think most of the sort of medium business companies that will be looking at this won't spend the time on it, but if you were a service provider, you would definitely be doing the analysis on that one.
Indeed.
All right. Do we need any other parts for hyperconverged? I think we probably want to kick on in and have a look at the benefits, and I think that the simplicity and uniformity, there we go. I've got the scalability grown by adding small units in here. That I think is one of the big benefits, and we've talked a little bit about that convergence of storage and compute management down to the virtualization team that often has been the Windows team because they had the biggest problem with DLL hell, leading them to need lots and lots of virtual machines and therefore having a need for virtualization or lots and lots of separate copies of Windows. I also really like that with a typical hyperconverged infrastructure, as you add the capacity to run more virtual machines and as you add more capacity to store those virtual machines, you also get more performance because there's essentially a storage controller in every single node that you buy. I think that's one of the key things about scaling a hyperconverged infrastructure is that you typically don't, if it's been well designed, you don't end up with single points bottlenecking performance. And I think, Stephen, you can talk a little bit about how you see that as being very beneficial.
Yeah, no, definitely. I mean, so if you look at kind of like a traditional three-tier approach and you procure an array with, say, 4 servers, and your array is capable, just say for an example, of 100,000 IOPS. If each 4 of those servers were to concurrently use the array to its full potential, each one would actually be only able to get 25,000 IOPS. If you were to increase that to 10 servers all trying to max out the array, each one's going to get 10,000 IOPS. So essentially, as you scale out your compute, you're essentially limiting or decreasing the storage performance per compute node. And so one of the key things for hyperconverged, as you mentioned, is when you actually scale out your compute resources, you're scaling out your storage capacity and performance as well. Because there's local controllers on those nodes with local SSDs and local storage resources, as your compute and virtual machine workload grows, so does your storage performance. And that's an important thing with identifying bottlenecks. If you do that with the traditional three-tier approach, you have to additionally add additional controllers, new DAEs, larger cache sizes, et cetera, and that just becomes extremely complex. And that's what really kind of scares a lot of people away from having these rapidly scaling environments. And with hyperconverged, it's just really all built into the product and the platform natively due to the architecture.
Yeah, I think that does indicate some of the kinds of use cases where hyperconverged is just so hugely beneficial. And it's the use case where you know that you're going to have a progressive and potentially explosive growth in workload. Kind of use cases that I can think of is my favorite VDI deployments are ones that start small and progressively grow rather than trying to big bang 4,000 users over a weekend. They'll bring on 300 users every week or every couple of days for a few months. And those kinds of scale up use cases are definitely scale out, but scale up in terms of workload, scale out for the infrastructure. Jesse, how do you feel on this one?
I mean, I think that scale is key, and if we look at, I tell customers a very similar story to what Stephen was just talking about, which is sometimes we get questions about, well, I'm looking at an all SSD solution. So, okay, well, what's the all SSD solution going to do? Well, it's going to deliver 100,000 IOPS, and then you have the exact same discussion that Stephen just talked about, which is as you expand the number of nodes, you end up dividing down the functionality of that system. And you very quickly in a hyperconverged environment, as you add nodes, end up with more performance than you would regardless of what the back end is, simply because you're scaling resources together and you're adding them together. So I agree with the point, and I think it's a really valuable one that those resources are made available incrementally to the user.
Mike, have you got any other benefits of hyperconverged that are striking you, being the newest of the players in the hyperconverged space?
I think definitely simplicity is key. I think when it comes to something like the Evo Rail, the target is to be able to send one of these appliances to a site with it not necessarily needing PSO or some guy out there to configure it. That's the goal. As for scalability, yes, growing is great, but I was having like a discussion with the VMUG in Yorkshire just the other week about scalability around the Virtual Center appliance and looking at the differences between the Virtual Center appliance and the Windows version of Virtual Center. And the number of customers who say, we've only got 3 ESX hosts or 6 ESX hosts or 8 ESX hosts, the scalability issues weren't really that important to them. And I think we have to recognize, say, in an SMB environment, sometimes you put these things in and they don't grow. I've gone to some SMB customers where, you come back a year later and they've still got the same number of VMs they had at the beginning of the year. So scalability obviously is useful for environments that are growing, but I also think it's important that the appliance, be whatever it is a right fit for an organization that only needs a certain amount of compute. Same goes with robo or retail locations. Sometimes those locations, they need a certain amount of capacity, but from one year or one quarter to the next, they're not really changing that much. So I don't want to over-egg the scalability. It's important, but there are some environments which are kind of static and fixed as well that don't change that much, and we've got to recognize that as well.
Yeah,
I agree with that, Mike.
Yeah.
I think the one thing I would add to that. Sorry, go ahead, Stu.
No, you go.
Oh no, go ahead, Jeff.
So the one thing I would add to that is even in those small environments, in some ways they are the highest risk. So I agree completely that there are some that are static, but in the mid-market customers or SMB space, the percentage of their budget they invest to buy some centralized storage device, for example, is a huge portion of their budget. And the risk, if they size it incorrectly, is so high to them to having to buy another one, that for them the risk mitigation of putting in something that enables them to scale, even if it's just from 2 systems to 3 systems, or 3 to 4, whatever the number is, I think is a huge value in that piece of the market.
Yeah, I've seen a small. I'm from New Zealand. Almost everything is small to small, and I've seen a customer who had spec'd their storage system incorrectly. Then they had made a relatively small RAID 5 array out of slow disks, and oddly enough, the write performance was awful, and the cost to them to upgrade it to more spindles so that they could have adequate capacity with a RAID 10 solution was a significant piece of budget that had to go all the way to the top of the business, and they were deciding what else the business was not going to do in order to accommodate that change. So I agree with you that although the small business environments are by definition small, the IT decisions are a big piece of their spend, and they are a big risk for those organizations. One of the challenges in this scale-out architecture is actually going down to a small scale. And a lot of organizations, if you look globally at the number of commercial organizations, the vast majority of them have less than 50 staff and are likely to be running a single-figure number of virtual machines. A solution that requires multiple physical servers struggles to scale down to that, given the vast amounts of CPU and memory we can push inside one piece of tin. So that's one of the challenges at the lower end of town, is simply scaling down these kinds of solutions.
Yeah, and one of the other benefits, just to briefly highlight it, is also around the whole kind of consolidation / density of this as well. As if you look at a lot of the platforms, there's 1, 2, or 4 server nodes within a TU footprint. You don't have to have separate rack capacity for storage for your SAN as well as your compute. So to kind of Mike's point for the robo scenarios where the simplicity part's key. Simplicity, absolutely, I would say simplicity is extremely beneficial for those customers. But then also, you can have the simplicity that within a 2U unit, you can have an HA environment from both a compute and storage perspective throw in 2 switches there for HA on the switch side, and within 4U, you have a fully HA environment that you can deploy at a branch office, compared to the traditional approach where you might need at least 2 to 4 to 6U for an MSA or a small array, and then your compute side there as well. So the density and the consolidation side is definitely another benefit of hyperconverged as well.
Particularly in those remote office, branch office environments where this is being stuck in a cupboard under the stairs. And I do recall sitting in that cupboard with my laptop on my knees for one customer. All right, well, I think we've had the happy, friendly environment for so very long that we need to start thinking about differentiation between these products. And I wanted to give the opportunity to discuss how each of the hyperconverged vendors' products are different, which is starting out with Nutanix and Stephen to talk about how Nutanix, which was the first hyperconverged platform I learned of, and obviously I teach about their products and like them a lot. What is the difference? What is the special sauce in Nutanix?
Yeah, no, absolutely. Well, realistically, thinking back on it, I mean, we really were kind of one of the first, or if not the first, hyperconverged platforms to really hit the market. And obviously, we've seen a ton of demand for hyperconverged infrastructure. Obviously, I have to have the first point in there just to make the marketing guys happy. But, we have over 800 customers across 43 countries. And, it's not just, specific to Nutanix. I think one of the broader things just from a hyperconverged standpoint is the fact that, people are really excited about hyperconverged platforms. And that's really, an extremely good thing for all of us here today. Just given the demand and the increase in exponential growth and demand there. One of the key things early on for us was, really about giving the customer choice. Obviously, initially we started with ESXi as our core hypervisor. It's the most heavily used hypervisor out there. But we also had kind of the foresight that, we really wanted to give them choice in terms of, hypervisors. And so architecturally, we actually run as a virtual machine in user space as compared to kernel. There's pros and cons to both, but one of the key things that it allowed us to do is really be hypervisor agnostic. So today we have support for ESXi, KVM, and Hyper-V, and we've actually seen great demand for all of them. Obviously, a lot of the production workloads are ESXi focused, but for the robo deployments, and then also with Server 2012 R2 and the great advancements to Hyper-V, there's been massive, increases there. And then actually one of our larger customers is running a few thousand nodes on KVM for a big data deployment. So, really kind of all over the space, but that's really one of the key things is we wanted to give that flexibility and choice back to the customer. One of the key things for any hyperconverged platform, and, we were talking about this previously, compared to the traditional 3-tier architectures, but for these hyperconverged systems, really some of the focuses are around eliminating any single points of failure and bottlenecks. And so that's one of the key things to us is, a lot of people will bucket us as hyperconverged or software-defined storage or web scale, et cetera, which is true. But when I kind of boil it down to what our core competency is from an engineering perspective, realistically, we're a distributed systems company. That's our core DNA. That's our core blood. And one of the key things for that is, by being a distributed system, we run all of our services and all of our components within every single controller. And so we talked about how when you scale compute nodes, you scale your storage performance. That's absolutely critical. But then there's also the kind of control plane that I would mention as well. And so for us, all of our services, all of our deduplication, compression, our data protection is actually running on every single controller VM. We have a MapReduce framework which we leverage for performing any cluster-wide modifications, tasks, etc. And so the key thing for that is no matter what scale, if you're 3 nodes, if you're 3,000 nodes, you actually can ensure that you have linear performance at any scale, which is extremely important. The other thing is on the availability front. If you lose a node, if you lose a controller, with block awareness, if you lose a full block, you have that protection. If you take down, for example, one of our controller VMs, which is what we do during our rolling upgrade process, which is non-disruptive, the virtual machines on that node don't actually notice that that controller VM is down. And so that's where the distributed systems piece really comes into play. And then, the other piece is data protection. So, all of us, we leverage what is called a replication factor for data protection. And essentially what that means is you have your primary copy of the data, and you'll have 1 or 2 or n number of copies of that data dependent on the RF. Most places and most companies leverage a replication factor of 2, which means there's going to be 2 copies of the data always available within the system. And so, kind of coming back to the pure distributed standpoint is during data ingest, whenever a new write comes in, all nodes within the cluster can handle different portions or pieces of those replication ops. So, for example, if you have a 8-node cluster and a virtual machine running on node A and 7 writes come in from that virtual machine, one of those replication ops can be handled by each node within the cluster. And that's extremely important. If you have 32 nodes within the cluster, each one of those 32 nodes can handle some of those replication ops. So that's really important when you start talking about the performance as you scale and as you grow. As kind of a corollary to that, if you're replicating to a single peer or node within the cluster and that node is under duress, that could handle and basically translate into front-end latency for the virtual machine that's trying to write that I/O. And so that's where, on the back end, you can actually prioritize that logic to re-replicate to not a busy node, but to other nodes which are more idle within the cluster. The other piece is from a data availability standpoint or data protection. So with replication factor 2, you have 2 copies of the data. So if you lose both copies of that data, you have data unavailability. And so that's where we have replication factor 3 as well. So essentially with replication factor 3, you have your primary copy, then the 2 replicas, and then if you bundle that with what's called availability domains, basically AKA, I call it the technical term for it is block awareness. Basically block awareness ensures that when you write a copy of the data, the replica of that copy would exist within a different block within the environment. And a block for us is realistically just a chassis which can hold 1, 2, or 4 server nodes. So if you have a 3-block deployment, which could be 12 nodes, you can actually lose a full block, which is 4 nodes, and still have 1 or 2 copies of that data available, which is a very important thing. The other piece is from a rebuild. If you lose a node, say a hardware failure, or you lose a drive, etc., all nodes and all controllers and all disk devices are actually concurrently being used to rebuild and maintain that replication factor, leveraging that MapReduce framework that I mentioned earlier. So that's extremely important because you're not limited by a single peer's performance or a single node's performance. You're basically using the full performance of that cluster to actually perform that re-replication for the RF.
That's kind of the distributed steering that we see in wide striped arrays coming into play to get your rebuild times down to minutes rather than days.
Oh, absolutely. I mean, realistically, same thing kind of goes with a RAID rebuild on an array. Essentially, you want that rebuild to be ideally as fast as possible because, if you're at, if you have to calculate parity, obviously there's concerns or issues on the array side. And same thing for, hyperconverged platform is you want that replication factor to be maintained very rapidly. So if you lose a node or a disk, that data on that, if you're at a RF2, you want that to be re-replicated extremely quickly. And so if you have, an 8-node cluster, all 8 of those or 7 of the remaining nodes can help rebuild. And, as you scale, that rebuild efficiency actually gets even more efficient because, if you went to 32 nodes, you actually have 32 nodes that are concurrently re-replicating that data. So yeah, absolutely, that's extremely critical to get those build times down. And kind of the last bullet on this page here, and kind of goes along with the whole hypervisor agnostic piece is, we didn't want to rely on any, bottlenecks or single points of failure, and which means, we don't integrate or rely on any of the third-party or hypervisor management tools. So for example, we don't have a strict coupling or reliance on vCenter or SCVMM, etc. And, one of the key reasons for that is, as mentioned previously, we don't want to have any single points of failure or have reliance or tight coupling to that. And, even at Accenture with some of the Fortune 50, Fortune 100 companies, a lot of people weren't using things like vCenter Heartbeat or SQL Server clusters or SQL Server always-on availability groups. And, the thing is if vCenter goes down or there's an HA event, it's going to have to restart. But if your database goes down, you're going to have to, not have access to that management tool. And so that's where, one of the approaches that we've taken is to directly integrate with the hypervisor to perform operations. So all of our stat information, all hypervisor interactions all occur directly to the hypervisor and don't go through one of those management tools. And the key thing is just to make sure we're not tightly coupled on something which could fail. And if we could just go to the next slide. Cool. So this one realistically applies to all of us here today. So if you look at EvoRail, SimpliVity, Nutanix, one of the key benefits to us, and this was previously covered earlier, is we ship as an appliance. And one of the key things for that and key benefits is the fact that the full stack is validated. So for example, we have a fully dedicated hardware team which ensures that this SSD with this controller, with these hard drives, with this sort of chipset, these motherboards, this power rating, that all works perfectly and as you expected. And so with that, we know what the MTBF is. We know the availability and reliability of the hardware. It's all been vetted and validated. And then the other piece is just a single vendor or single sourcer, as well as single throat to choke. And this is one thing that a lot of the larger guys really like about VC or FlexPod. You can go to one company and say, I want this, and that's it. You don't have to worry about going to, say, Dell for servers, EMC or NetApp for storage, Brocade for your SAN. You can do that all through one single vendor, and that's an extremely important thing. Second point, obviously, we've all heard a lot about this, the whole kind of software-defined asterisk revolution, but one of the key things is, everything we do is in software. All of our control plane, all of our data plane, all of our DD compression, etc., is all within software. We have engineers internally which actually run our software on desktops. So, you can run it realistically on any hardware, so we don't rely on any of those proprietary hardware, any proprietary hardware. So it's all commodity. We ship Supermicro hardware today. It's all out of the box hardware. Realistically, all the goodness for us is in our software. And then the last piece, just to kind of finish it off here, is we understand it is a big shift coming from the three-tier approach to hyperconverged. I'll admit, before I joined Nutanix, I loved vBlock and FlexPod. And I was like, oh, there's no way you could do vMotion or have, centralized quote-unquote storage array, which was using DAS. And I very quickly became a quick believer. But, the thing is we've been so used to this three-tier architecture, organizationally, technically for so long, that hyperconvergence really is a massive change to what we're used to. And, as part of that, we understand that it is a massive change. And rather than, just saying this is the way, we actually want to help people understand, what's the change, how is my data protected? If you want to worry about how we do deduplication, we'll tell you how to do that. If you want to know how your data is protected compared to traditionally what you do with RAID, how does RF compare to RAID? We want to explain that. So, it's really a journey where, it's kind of a massive shift in thinking going from the three-tier to hyperconverged. And so as part of that, we're very open about our software and kind of general hyperconvergence and how we do things internally. So, for us, we don't want to be a black box or anything, and we're very open. And so something near and dear to me is obviously the Nutanix Bible, where we go into a lot of the technical details about how that stuff works. And, this will always continue to evolve, but we do want to be very open about that. And then also at the end of the day, if we think about IT, IT realistically, infrastructure is more of a means to an end versus the end. At the end of the day, IT is really focused on applications, use cases, and services. So as part of that, we want to really help customers be successful in terms of how you bundle application end with hyperconverged platforms. So as part of that, we have a ton of reference architectures and best practices guides which are available. Really focused on how to design and architect solutions for hyperconverged platforms. And so with that, I think I'll hand it over to Jesse, unless there's...
I just wanted to say thanks again for the Nutanix Bible. I know that as I'm teaching the training courses, it was one of the top things that I would refer students to, of that you need to go here and you need to go and check it when updates come out, because that's where I go to learn about the Nutanix platform. Also that it's my buddies down in ANZ are some of the people who are producing some of those reference architectures.
Yep. Oh, yeah. Josh, Michael, and all those guys. Yeah,
Yeah,
absolutely.
yeah. All right, thanks for that, Stephen. And as you say, we'll move on to Jesse to tell us about SimpliVity and its core innovations and the things it does.
Sure, thanks. So there's I think you'll hear three viewpoints on hyperconvergence that have some parallels, but also have some differences in how the problem is approached. So one of the core things that we looked at when we looked at the problems in the customer's environments was really there was this giant data boat anchor in the customer environment. We have this great video that shows these little VMs, cartoons running along the ground, and then you realize there's a tether on their leg, and they face plant, and it zooms out to you see this giant data block behind them. So this idea of data efficiency and data mobility is really at the core of what we've built. So SimpliVity delivers inline deduplication, compression, and optimization of all of the data in our system at the time of ingest. So before data ever hits a hard drive in our system, it's been deduplicated, compressed, and optimized at a fine-grained level, and it keeps it in that format for its entire life. So it doesn't matter whether that data moves between data centers, whether it's in DRAM or flash or the hard drive, it never has to be reprocessed. And this really comes back to the efficiency question. We looked at environments where the same data was being processed easily 8, 10, 12 times. We wanted to solve that problem as high up in the stack as possible. So right next to the application, compress it, deduplicate it, optimize it. And what we looked at was how do you do this in a way that's viable in the market? One of the challenges historically is that data efficiency technologies were focused on the backup or the archive market. It was about how much data you could pack into a single hard drive. That's what the backup to disk guys did and a number of other folks. Our approach had completely different priorities. The number one priority was reduce hard drive IOPS because that's a limiting factor in the data center. Number two is reduce WAN bandwidth, again, a limiting factor. Number three, optimize the flash capacity. And number four, optimize the hard drive capacity. So yes, we do it, but it's not really the primary objective. So the way to do that and still keep the economics, the best dollars per VM economics in the data center is we rewrote everything between the device drivers and the NFS at the top of the stack. So our code is 100% our own. That runs, as Stephen used the example, our guys run it on laptops. We do development on laptops, desktops, all over the place. When we deploy in production environments, we leverage what we call the OmniStack Accelerator, OmniCube Accelerator. And we have a hardware team in-house that's designed and developed this. This is part of our intellectual property. And this allows us to do all that deduplication, compression, optimization inline, and actually deliver a net positive on the performance side. There's no negative impact. There's no negative impact to performing these operations. So if you can eliminate the IOPS before they hit the hard drives, there's a huge benefit to the end user, to the performance of the system. So if we go to the next step, here we get global federated management or global unified management. And this for us is a lot of the things we've talked about. It's the ability to do management of the system, and really our objective here was to become as simple as possible. We felt that the best way to do that was to effectively disappear. So whenever possible, we've just disappeared into the end user's workflow by managing the entire system through vCenter. All of the policies in our system, all of the management is done at the VM level. So a user's definition of a policy is very simple. How often I take a backup of this VM, how long do I keep that backup, and where do I send the data? And the policy is completely abstracted from the infrastructure. So there's no definition of IP addresses. You don't have to manually define sites. You don't have to define any of the underlying infrastructure. You just right-click on a VM, say back it up to some site. You pick the site happens to correspond to a data center that comes right from vCenter, and the VM just moves there. Again, because of the global nature of our data virtualization platform, it moves there deduplicated, compressed, and optimized. So this global unified management allows you to add nodes into the environment with no reconfiguration. It allows you to take nodes out. It also allows you to do a complete tech refresh of a data center. So you could go into an environment that had some OmniCube systems in it, add some new ones, slosh the data over onto the new systems, evacuate the old ones out, and with no downtime, no manual data migration, no professional services engagements, none of the risks that's associated with typical data migrations, and nobody sitting in the data center to hold hands of a data migration. Everything just flows. You get an alert in vCenter that says the OmniCube evacuation is complete. Turn it off, unplug it, take it out of your data center. Also includes the ability to scale out. So scaling out a node at a time is really, again, designed to simplify it for smaller customers. To Mike's point from earlier, larger customers may scale out in much larger increments, or you may have fixed customers, but that's a piece of that as well. And the objective there is really to simplify operations of the environment. The last thing is what we've been talking about this whole discussion, which is really about hyperconverged. So this is taking as many of the functions as possible in the data center: server, storage, backup to disk, WAN optimization, and reducing the amount of traffic that moves between storage systems, cloud connectivity, all of these other devices in the data center, and collapsing them down into the OmniCube technology. It's all about the dollars per VM. In the end of the day, the cost is the driver, the economics are the driver, and this harkens back to the accelerator card that we've built. This helps you run more virtual machines with less infrastructure, and the economics are actually favorable. It's less expensive to run VMs in an environment that leverages that technology. So it's all about those dollars per virtual machine. And then the efficiency here is really, if you can process that data once instead of 6, 8, 10, 12 times within your environment, that's a huge difference for the data center. And the last thing is, it needs to, part of hyperconvergence that we think is key is also plugging into the existing data center infrastructure. So not forcing customers to change the way they manage their environment in ways that are different, but just eliminating steps, right? Not building a new island in the data center. So we let them, for example, connect to existing ESX servers. The ESX servers can leverage our data store, get all the benefits of VM-centric policy, all that abstraction, all managed through vCenter without having to, if our exact CPU, memory, disk ratio isn't perfect for a specific customer, if they want to leverage existing investments in server systems, they can do that with our environment.
One of the things I really liked is you're talking about the system disappearing, and I think this is one of the key things, is that IT infrastructure, like any other infrastructure, you only notice it when it's going wrong, and you can tell that it's going right because nobody knows it's there.
Yeah, exactly. And from our perspective, it's why we embraced the users managing the environment through vCenter. The customers already have tools to look at the errors and monitor alerts through vCenter. They already understand what tasks in vCenter mean. So all of our alerts, tasks, alarms, all that stuff just reports up into vCenter. So there's no new console to manage within the environment. It's a very natural thing for an end user. The analogy my CEO uses is instead of getting to the airport and you get in your rental car, you don't have to read the manual. You just adjust the seat, figure out where the headlights are, and you can drive away. And that's the objective. If you know how to manage VMs through vCenter, figuring out how to right-click on things and take an action should be pretty simple.
And I particularly like also that this is the only converged infrastructure solution I've seen using, or hyperconverged, using commodity x86 servers, yet has custom silicon inside it. And I'm always intrigued when people start using custom silicon to get some benefits, because my degree involved some design of custom silicon.
Yeah. It turns out that dedupe and compression are extremely CPU-intensive operations, and if you want to deliver them without a performance impact, you either throw an enormous amount of CPU at it, which still drives up your latency and your cost, or you optimize it, you offload it, which is the choice we took.
Cool. Now our final vendor is Evo Rail, and although I talk about them as being a vendor, they're not really a vendor of the solution. So Mike, run us about what's special about Evo Rail.
I guess if you're looking for what's special and what's different is, I think I mentioned earlier that hyperconvergence hasn't converged around a similar solution. So the big thing with Evo Rail is it deploys a vSAN cluster for you. So it's 100% VMware. There's no controller VM involved in this appliance at all to actually present out the storage. As you might know, vSAN is embedded in the kernel. And then I guess the other thing that is different about Evo Rail is the business model is different. So VMware isn't getting into the hardware market. We're not buying servers and taking the bezel off the front and putting our own bezel on. We've gone for a route to market which involves working with an existing set of partners, which you can see here on screen, Dell, EMC, and Fujitsu, and then also Supermicro. So the way I like to look at what we're doing is that we've enabled our partners to create a competitive market for hyperconvergence. A lot of people have come up to me and said, you know, is evo-rel going after vBlock, or is evo-rel going after one of the hyperconvergent vendors? And I don't really see it that way, because it's not so much VMware or evo-rel that has joined the market. It's these partners who previously didn't really have an offering of their own that they could deliver to customers. So in a way, they're competing with each other for business, but they're also competing in the general hyperconverged market. So that's a big difference for me. And moving on to the next slide. Just to outline the sort of physical capabilities of the evo-rel appliance. It's a 2U box with 4 servers, blades, if you want to call them that, inside the servers. 48 CPU cores altogether for those appliances, about 768 gigabytes worth of memory. In terms of writable storage, 14.4 terabytes worth of writable storage and about 1.6 terabytes worth of flash capacity. Each one of the nodes on the actual appliance itself has 2 10 gigabyte ports. So if you have 4 of them, that adds up to 80 gigabytes worth of bandwidth. And 4 appliances are used, so you have not just a vSAN cluster, but also a spare node for maintenance, because as you might know with vSAN, the minimum is 3 physical servers, but it's often useful to have a 4th node for patch management and maintenance and things like it. And in the next slide. So we're looking at a scale out of 4 evo-rel hyperconverged infrastructure appliances in the first instance in this release. You can add another 3 appliances to the first purchase up to 16 ESX high hosts, and it discovers the appliance using IP version 6 auto discovery and something called micro DNS. So you don't actually need a DNS environment stood up in order to build the appliance. But the main point here is after you've built the first appliance, you can add another appliance, you can add another appliance, you can add another appliance, and it will automatically discover that appliance that's been added to the network. And from a pool of IP addresses, a range of IP addresses for management, vMotion, and vSAN, automatically add that appliance into the cluster. So in terms of how long it takes to set up one of these appliances, about 15 minutes or less in some cases to actually set out the initial appliance. So, and that's all done by this automatic discovery process. The best analogy I've been able to come up with for this is it uses something called zero network config. And if you've ever had an iPhone and an iPad and a MacBook all find each other without having to tell each other what their IP addresses or names are, you've used something like zero network config. In Apple, it's called Bonjour. In VMware, we wrote our own version of it called Loudmouth, and that's where a lot of the sort of internal intelligence is going on in the appliance, which you, although you consume and use as an end user, you don't actually see that protocol working in the background. And over the next slide. The other big development, I think, with the evo-rel, and one of the big advantages is as you're just dealing with VMware and then one of our qualified partners, the patch management process and upgrade process should be relatively straightforward and painless, because you're dealing with the same cadences of releases of vSphere. So as a new version of vSphere comes out, we'll make it relatively easy to upgrade that environment. So we're not doing anything different here. There's not like a custom version of ESX or a custom version of Virtual Center or a custom version of vSAN. It's the same version you could have installed manually, and that makes the upgrade and patch management process very easy to automate, because we're dealing with software that's been around for in excess of 10 years. So although evo-rel as an entity is new to the market, a lot of the technologies that we're automating the deployment for have been around for a very long time, such as Virtual Center and ESX, in excess of 10 years worth of use in some people's environments. So the update system within evo-rel doesn't use VMware Update Manager. The team have developed a brand new version, brand new method of doing upgrades, both of the appliance itself and all the software that it helps you deploy. And then I think I might be on to my last slide or penultimate slide. This is a kind of screen grab of the monitoring side of things. So over on the left-hand side, you get a very simple dashboard. This is a sort of management front end of the eVoRail. It's a very stripped down environment, deliberately so. So this particular window, you're looking at the kind of health status of the appliance. But from the appliance, you can create virtual machines, clone virtual machines, get a window on a virtual machine. And this sort of UI is intended for maybe an SMB or robo style environment where the main thing that people do when they actually consume the appliance is create virtual machines. Now, the main thing to mention about this particular UI is you're not limited to using it. If you want to crank up the vSphere client or the web client against the appliance, you're more than free to do so. In fact, there are links from this UI that allow you to escape out of the UI of the eVoRail and just use the web client as you would normally or the vSphere client as you would normally. But this particular UI has been developed with the appliance in mind, specifically indicating the health of the system, how much CPU, memory, storage capacity is still available. And then I think I'm on to my last slide.
You must have taken your last slide out, Mike.
I was trying to do it quickly because you said I talked too much. So
I did. I think you're well known for being loquacious, and even now that you're not drinking so much, you still have plenty to say. And I have to say, it looks like you were at a time with the other guys as well. So
closing statements, I guess?
Yeah, go on.
Yeah, I think for eVoRail, you're talking about something that's 100% VMware. But at the same time, there is the possibility, certainly if you're a Dell, EMC, or Fujitsu customer, to potentially use the same OEM you use to acquire your other hardware as the main route to getting a hold of eVoRail. We were very pleased to have such a wide range of partners join the eVoRail program when it was launched just a few weeks ago, but we won't be stopping there. We want to add more qualified eVoRail partners, or QEPs as I was referred to that list. So watch this space for other vendors coming into the hyperconverged market. And we often talk about commoditization, and I think the introduction of eVoRail is driving this hyperconverged market in that direction. Up until this point, there's been a limited number of people that you could get such a technology for, and what VMware has done is enabled its partners to enter a market where they previously weren't. And I think that will drive up choice, and it will drive up quality as well, because the more players there are, the more there's a competition between different vendors, both on price and also on quality.
Excellent. Well, thank you very much. I think we've run well through our time. I like to keep a short podcast, and we're definitely well over the hour. It has been a pleasure to discuss the benefits and the issues that are addressed by hyperconvergence. And I'd like to once again thank my three guests, Mike Laverick, Jesse StLaurent, and Stephen Poitras, for joining us here and talking about this. We will be discussing some more things on further vBrownBag extra podcasts over time, and do check out the full podcast on iTunes. All right, I think I'll close it out at